So we'll look at stresses in cylindrical pressure vessels in this next example. So in this question, we want to know what is the maximum pressure that a thin-walled cylindrical pressure vessel can withstand if that pressure vessel has a radius of 3 feet, a wall thickness of 1 inch, and stresses are not allowed to be above 50 ksi. So in this one, we'll remember that there's two types of stresses in these thin-walled cylindrical pressure vessels. There's the hoop stress. So let's define those. Hoop stress is acting in, if we were to draw a stress element on our cylinder, the hoop stress is acting in the circumferential direction, and the equation for the hoop stress, sigma 1 equals PR over T, and then the other stress that we'll see in the cylindrical pressure vessels is the longitudinal stress. So if we go back to this element, the longitudinal stress acts along the long axis of the cylinder, and we'll label that stress as sigma 2, whereas the hoop stress was sigma 1. And the equation for longitudinal stress that we showed how to derive in the lecture is sigma 2 is equal to PR over 2T. So here the question's asking what's the maximum pressure that we can have. So the max pressure is, so it's the max pressure that we're concerned with given that we have a certain stress that we can't go above. So if we look at both of these equations, we'll notice that for the same pressure, stress is going to be higher in the hoop direction than it is in the longitudinal direction. So we really just need to look at what the hoop stress is, since that's going to be the limiting stress that will define our max pressure. So what we're going to do is rearrange this hoop stress equation to solve for pressure. And we're going to call pressure P max since we're solving for a maximum pressure. So we just simply rearrange the equation and say P max is equal to sigma 1 times T divided by R. So the maximum sigma 1 that we're allowed to have is 50 ksi. So that's 50. I'm going to write it in PSI just to have consistent units. So, and that's PSI being pounds per square inch. So 50 KSI is 50,000 pounds per square inch. So actually I'll just write 50,000 instead of writing scientific notation. So 50,000 PSI. The wall thickness is 1 inch. And the radius is 3 feet. 3 feet is 36 inches. So I just converted the units on the fly here just to make the math easy. So you'll notice here that the inches are going to cancel out in this equation, and we'll just be left with PSI. PSI is the units for pressure. So if we put this in a calculator, we're going to calculate the maximum pressure we can have for these conditions is going to be 1,388.9 PSI. Okay, so that's how you use the equations for cylindrical pressure vessels.